Alright, so we're going to be looking at finding the formula on a straight line graph, and this is just when you'll be asked to determine the function of any straight line on a Cartesian plane. You'll be given a Cartesian plane with a straight line drawn on it, and your job is simply to find the formula. This is really simple to do if you break it down into two very easy steps. First, let's just quickly look again at our standard formula, which is y equals mx plus c. X we know is our input, y is our output. M and c are the numbers that are going to make our straight line look different from any other straight line. M we know is our gradient, and c is our y-intercept. I'm going to show you how to use these two to find the formula for any straight line on any Cartesian plane. So the first thing you do is you find C. Have a look at these two graphs. What is C again? C is our y-intercept. It's where the straight line, this straight line crosses the y-axis. So we can see this straight line crosses the y-axis at -4, whereas this straight line crosses the y-axis at 4. So that is our C values. So we find C, simply look at the line. Where it cuts the y-axis is its y-intercept. Our first graph, C is -4, our second, C is 4. And now we can simply plug this value into our standard formula in place of C. So the first graph will have y equals mx -4, because it cut the y-axis at -4. In the second graph, we have y equals mx plus 4 because it cuts the y-axis at positive 4. So we've got C. The last thing we need to find is M. M is our gradient. To find the gradient, we use our gradient formula. We need two sets of coordinates, and then we just substitute them into this formula that we know already. M equals y1 minus y2 over x1 minus x2. It's simply the change in y over the change in x. And regardless of which coordinates you choose, you're going to get the same value. The gradient is the same for the whole line. Let's look at an example together. Alright, so first we know we want to find C. C is simply the y-intercept. This straight line cuts the y-axis at -2. C is going to be -2. Our next job is to find M. So I know I have to choose two coordinates. I can choose any two coordinates along this line. I'm going to choose this top one here where it cuts exactly, and that's 10 and 3. X is 10, y is 3. And then I'll come down here and choose -10 and -7. Because it cuts the line exactly. I could have chosen anything. Sometimes it's easier to choose our x-intercept and our y-intercept, because then our sum is pretty easy. But I'm choosing those ones. Find M, I've got to plug these into my gradient formula. So M equals, and there you have it all out there. Pause if you'd like to go through that slowly. But basically on top I have my change in y. At the bottom I've got the change in 10. I simplify it and I get M is equal to 1/2. Now I have C and M. I can substitute those values into my standard formula. So y is going to be equal to 1/2x minus 2. And that's it. There's some special cases that you can look for. We have first one, our horizontal line. You can see our horizontal line cuts only the y-axis. So for every point of x, y is equal to, you can see y is equal to 5. So only cuts y-axis. We find what the y value is, it's 5, and that's what the formula of the line is. Y equals 5. You can see there's no gradient, so 0 times x is 0, so there's no x. We've just got C, the y-intercept. We could also give you a vertical line like this. It doesn't cross the y-axis at all. It has a gradient that isn't defined, it's vertical, and we can see it cuts the x-axis at -5. So that's it. Line is vertical, only cuts the x-axis at -5, and that is our function, y equals -5. Lastly, we've got this axis here, this function which I didn't write it in, but it's at a 45-degree angle here, and we can see that because for every value of x, y is exactly the same. When x is 1, y is 1. When x is 2, y is 2. So we know that this angle has to be 45 because that is 90, and that has to be 45 as well. It has to be an isosceles triangle. So with this, our y-intercept is 0, our gradient is 1, so this is simply y equals x. And those are the special cases that you should watch out for.